So today we're going to cover section 3. We're going to learn 2 formulas that you'll need to memorize. We're going to learn the midpoint formula and the distance formula. But before we learn the formulas, let's define the word midpoint. So the midpoint of a segment is going to be the point that divides the segment into 2 congruent segments. Now, when we're finding midpoints, we're not going to find midpoint of a line because remember, a line goes forever. So when we're finding this midpoint, we're going to be finding midpoints of segments. The other word that's here, key vocabulary word, is a bisector of a segment. And a bisector could be a point, it could be a ray, a line segment, or a plane. And all of these things will intersect this segment at its midpoint. Now, when we are trying to identify a midpoint, if I gave you a segment and let's say I drew it like this, and let's say I put a random dot right here. Let's say I label this A, B, C. Now, B looks like it's right in the middle, but I can never assume anything in geometry. I can't say that B is the midpoint unless I'm told that B was the midpoint, or unless I'm given maybe the segment lengths to show that they're equal, or congruency marks. So notice the definition of a midpoint is that it creates 2 congruent segments. So if my figure has little marks like this, then I could state that B is the midpoint. Or let's say instead of the congruency marks, let's say the figure said, well, this segment from here to here is 5, and this is 5 also. So as soon as you see your picture is labeled and each segment that is on either side of that point are equal, then you know it's the midpoint. So they're either going to need to label your picture with congruency marks or label it with values, or say B is the midpoint of AC, okay? So you have to be told that it is. You can never assume anything. Now, a bisector, let's say we have our line segment. So it could be a line that goes through it. And again, you'd have the tick marks. It could be a ray that's going to bisect it. Could be a plane. And in the case above, it could be a point. Anything that's going to divide that segment into 2 congruent segments is a bisector. So it splits it into 2 congruent parts. Okay, and again, remember, we can't bisect a line. We can only bisect a line segment because we can't measure a line because it goes forever. Let's try the next example. Everybody good on this? All right, the next one is a application problem. So here it's stating that it's a skateboard, and in the skateboard design, VW, so this line segment right here, bisects XY. Now, I know it's kind of hard to see, but it does have congruency marks here in red. Now, they told me that it bisected. So by definition of a bisector, it makes 2 congruent parts, but it also had congruency marks. So it says that if XT, so from here to here, is equal to 39.9, how can we find the value or the length of the whole thing, XY? Yes? We can double it. So we can either multiply 39.9 by 2, or we can just add it to itself. So we need to double that length because, again, they're 2 congruent parts. So once I either multiply it, I get 79.8, or if I added it to itself. So that's how I could find the length of the whole thing, by doubling it. Pretty good? Anybody still need it? Let's try the next example. Okay, so now it's just a line segment, but this time we have expressions for the lengths. So again, they're telling me that M is the midpoint of VW. So M is the midpoint. Notice also I have those congruency marks. Remember, when we have the midpoint, it creates two congruent segments. So to find the length of VW, or VM, sorry, we're gonna go ahead and set the two segments equal to each other, solve for X, and then plug it in. When you're taking tests in geometry, you need to read the questions carefully. Now, notice when I go to set this up, I'm gonna set segment VM, which is 4x minus 1, equal to segment MW, which is 3x plus 3. Now, I need to solve for x first, but then again, remember, I'm not asking you to find x, I'm asking you to find the length of VM. So let's go ahead and find x first by subtracting the 3x, and then I get x minus 1, and then I will add the 1. I found the value of x, but my problem didn't ask for x. It wants the length of VM. So now I take what VM, the expression that was given to me, and I plug it in. And 16 minus 1, and the length of VM is 15. Now if it asks for the length of VW, I would double it. And it would be 30. Thank you. Okay, so that's how we can work with a midpoint. Again, you must be given either congruency marks or told that the point is the midpoint, or even given the lengths of them to know that something is a midpoint. Pretty good?
Yes, ma'am.
All right, let's try midpoint. So now we've learned the definition of a midpoint. Now we're going to learn how to work with the formula. Now, when we were asked to work with the segments and find the lengths of them, we could have subtracted, and they were usually horizontal or vertical. Now, sometimes when we're going to be doing these, it's not going to be easy. We'll have to use the formula, so we won't be able to find the middle of the segment. So this is where this formula is going to come in, because our lines may be diagonal. So these are going to be two coordinates, or two ordered pairs, and then I'm going to be plugging them into the formula. So I will add the x's and divide by 2, and add the y's and divide by 2. My answer is going to be a coordinate. So the x of the midpoint and the y of the midpoint. It's sort of like finding an average. So let's try and do an example of this given some coordinates. So here we go. So again, I'm going to label my coordinates that are given. Doesn't matter which one I call x1, y1, and which one x2, y2. So I'm going to call this one x1, y1, and this one x2, y2. Again, it doesn't matter. And now I'm going to plug it into the formula. So remember, the formula again is x1 plus x2 divide by 2, and then y1 plus y2 divide by 2. All right, so let's plug them in. So 0 plus 6 divide by 2.
Just 3.
and then 4 plus negative 2 divide by 2. So this will give me 6 over 2. This will give me 2 over 2. And then I get 6 divided by 2 is 3. 2 divided by 2 is 1. So this will be the coordinate for my midpoint. Now, the next one at first looks kind of scary. It's got a variable there in my ordered pair. But I'm still doing the same thing. This will be x1, y1, x2, y2. And I'll plug them in. So b plus 2 plus 3b divided by 2. 4b plus 2 over 2. Now, notice I can simplify this. If I want to reduce this, this 2 would need to go into both. I can't just simplify it with 1. So this becomes a 2b, this becomes a 1. So this will become 2b plus 1. Now, this is the x of my midpoint. Now I have to do the same thing for the y. So again, y1 plus y2 divide by 2. And then I get 6 divided by 2. And then that gives me 3. So my midpoint will be 2b plus 1, comma 3. This is the coordinate of my midpoint. We could say that, again, x and y. So the little m represents the midpoint. All right, so in example 4, notice I'm given the midpoint and one of the endpoints. I need to find the coordinates of the other endpoint. Now, because I've graphed them, I could figure out what the ordered pair is for k. But if you don't have a figure or you don't have a graph, then we're going to use the formula. So again, remember your formula is x1 plus x2 divide by 2, y1 plus y2 divide by 2. Again, remember, this is giving you the x of the midpoint. This gives you the y of the midpoint. So I'm going to go ahead and basically work with two equations. So I'm going to actually take this part and make an equation, and then this, and then plug in the numbers that I know. So in my given information, this midpoint is going to be the xm and the ym. This first endpoint could be my x1, y1. So I'm going to go ahead and work with the x's first. So I'm going to be using x1 plus x2 divide by 2 and set that equal to xm. All right, so now I'm going to plug in the two pieces of information that I have. I need to solve for x2. So x1 is 1. I don't know x2. And my xm is 2. Everybody with me so far? I now need to solve for that variable. So the first thing I'm going to do is get rid of that denominator. So I'm going to multiply both sides by 2. And I get 1 plus x2 is equal to 4. That little 2 is just a label. It's a subscript. I'll minus the 1. And the x of my endpoint that's missing so far is 3. I now need to do the same thing for the y coordinate of that endpoint. So again, I'm going to use the formula y1 plus y2 divide by 2 equals ym. So again, plug in what I know. So my y1 is 4. I don't know the y2. and my y of my midpoint is 1. Again, I need to solve for y2. So I'm going to multiply both sides by 2 to get rid of the fraction. 4 plus y2 is equal to 2. Subtract 4. And the y of my endpoint is negative 2. So the coordinate for my endpoint is the ordered pair 3, negative 2. Be ready to solve something like this on your test where you're working backwards from the formula. So again, we're tying in our Algebra 1 skills. I'm going to add an example that's not in the notes, just to give you an extra practice of it. So let's add a little example. So here, I'm going to give you the endpoint, or one of the endpoints is going to be negative 1, comma 3. And then I'm going to give you a midpoint that's 5, 6. So again, this could be x1, y1, and this will be xm, ym. Again, I'm going to use the same formula. So I'm going to do x1 plus x2 divide by 2 equals xm. And then y1 plus y2 divide by 2 equals ym. So I'm going to plug in. I'm looking for the other endpoint, which will be x2, y2. Now this example is not in your notes. I'm just doing an extra problem for you. So if you want to write it down, you can always add your page to Notability. All right, so let's try this. Let's plug in what we know. So my x1 is negative 1. I don't know x2. Divide by 2. The x of my midpoint is 5. I now begin the solving process. Multiply both sides by 2 to get rid of the denominator. And then I'm left with negative 1 plus x sub 2, or the x2, equals 10. Add the 1, and x sub 2 is going to be 11. Now I'll do the same thing to get the y of the endpoint. Again, plug in y1, which is 3. I don't know the y2. And the y of my midpoint is 6. Again, solve by get rid of the denominator. So 3 plus y2 equals 12. Subtract the 3. And my y2 equals 9. So my other endpoint, 11, 9. So be able to work backwards. Let's practice with the distance formula. Again, all you're doing is memorizing the formula and then plugging in the ordered pairs that are given. Pretty good on this example? All right, the distance formula. Okay, so x2 minus x1 squared plus y2 minus y1 squared. And then you square root your answer. Now, we're going to always leave our answers in simplest radical form. We will not be using calculators yet. So you're going to need to practice breaking down radicals. Okay? And I'll show you what I mean by that in a minute. Yes?
Why do we have a square sign if there's already an expression of the square root? Isn't that going to count it out?
Well, what we have to do is follow order of operations. So we're going to square it before we square root it. So you're going to square them individually and then add them together. So technically, yes, if you just had one expression under here that was squared, yeah, it would cancel out. But because you have to follow order of operations and complete everything that's under the radical first, it does give you a different answer. It's sort of like Pythagorean theorem. Okay? All right, so let's try this. Let's try it with an example with some coordinates. So the next slide, example 5. Again, let's label our coordinates. Again, it doesn't matter if P is my x1, y1 or Q, but I'm going to label P as x1, y1 and Q as x2, y2. And I'm going to plug it in to the distance formula. So let's go ahead and write it down just so it'll help us memorize it. So again, remember the distance formula, x2 minus x1 squared.
Y2 minus Y1 squared.
Good. And then the whole thing is under the square root. So let's plug in our values now. So we'll do 4 minus 6 squared plus -5 minus -3. Be very careful with your signs. So here, 4 minus 6 gives me -2 squared. This becomes -5 plus 3, which then becomes -2 squared. -2 squared is 4. I will add them, and I get 8. Now, because we're not using a calculator, we need to break down the radical. And I don't know if you remember this from Algebra 1, and we will be doing this a lot throughout geometry, is simplifying radicals. So when I have a number that's not a perfect square, I need to break this down, sort of do like a factor tree.
2 to the square root of 2. That's not true.
So the final answer, yes, will be 2 square root of 2. But for those that aren't as fast, let's go ahead and show them step by step. So if you're good at breaking these down into a perfect square and realize that 4 is perfect square, it becomes 2 radical 2. However, if you're not good at that, you're going to keep breaking it down till you get all prime numbers. And then when you have a pair, one of them will come out of the radical. And then anything that remains that's not a pair stays underneath. So this is an Algebra 1 skill. You will need to always simplify your radicals. We will not use calculators at the beginning. So simplest radical form, the length from P to Q is 2 square root 2. Now, even if you graph this, this would not form a vertical or a horizontal line, so you would not be able to count the spaces now. This is why we use the distance formula. So that is all of the notes for section 3. So you do have your homework assignment, which is due Monday. You can also start reviewing all of your vocab because you need to understand how to work with everything that we've learned in sections 1 through 3 for the quiz on Tuesday. Any questions?